Number 1 says find two numbers that do the following things. And if you get stuck, try listing the factors of the first number. So I'm just going to list the factors of the first number in each of these cases until we find it, just in case you are struggling. If you know before listing out all the factors, that's fine. So when we look at multiplying to negative 40, that means we're going to have one positive factor and one negative factor. So as I'm writing these out, remember that either one could be positive or negative. So I like to start with 1. So 1 times 40 is 40. And then 2 times 20 is 40. 40 is not divisible by 3. So when I say 3, I could do 3 divided by 40. That doesn't work. It gives me a decimal, so we won't list that one. 40 divided by 4 is 10. And then 40 divided by 5 is 8. And then 6 and 7 do not divide into 40. So here's our list. And then again, one of these needs to be negative. So if I just put a negative in front of, and actually I want to do these separately so that I can move them. So if we remember that we have a negative in front of these, this negative can move to either term. So what we're really looking for is that the difference between these two numbers is 6, so that when we add them together, they get to 6. So when we do this top one, we can either get 39 or negative 39, depending on where this negative is. So negative 1 plus 40 is 39. Negative 1 plus negative 40 is negative 39. So that's not what we want. This next one gives us 18 or negative 18 if we move the negative with the 20. This next one gives us positive 6, or if I move the negative over here, gives us negative 6. So for this top part A, we want to be using positive 4 and negative 10. Those multiply to negative 40 and they add to negative 6. And then if we put the negative with the 4, then they multiply to negative 40, but they add to positive 6 like we wanted. So if we have the 4 negative and the 10 positive, we would get part B. Then part C is asking us to do the same thing, but for negative 36. So again, I'm going to have 1 times 36. 36 divides by 2, and that gives us 18. 36 divides by 3 and gives us 12. It also divides by 4 and gives us 9. It is not divisible by 5. It is divisible by 6, and that is 6. And then again, we would have, it's multiplying to a negative. So one of them needs to be a negative. So if we just think about putting a negative with one of the terms right away, then we'll be able to move it to find what we want. So if we just look at this first set of numbers here, this would give us positive 35 the way it's written now, negative 35 here. Neither of those are the numbers we want. This would give us positive 16 if we added. This would give us negative 16. Again, not what we want. This would give us positive 9 here, which is what we want in part C. So we wanted negative 3 and positive 12. That multiplies to negative 36 and also adds to positive 9. And then we want negative 5. This next one gives us positive 5. Negative 4 plus 9 is positive 5. So if we have the 9 be the negative one, that will give us negative 5. So 4 times negative 9 gives us negative 36, and 4 plus negative 9 gives us negative 5. Number 2, create a diagram to show that x minus 5 times x plus 8 is equivalent to x squared plus 3x minus 40. So I'm just going to do the area model for this, where we draw the number of rectangles as we have terms on each. So I've got a 2-term by 2-term polynomial. And so I'm just going to write one of them along the side, so the x and the minus 5. And then I'm going to write the other one along the top, and that's x and positive 8. And then we'll multiply these in. So for this box, we have x times x, which is x squared. For this next box, we have x times 8, which is 8x. For this box, we have the negative 5 times the x, and so that's negative 5x. And then for this final box, we have negative 5 times 8, which is negative 40. And so when we take these terms out of here, we have the x squared, we have the 8x, which is positive, so I'll put a plus in front of it. We have the negative 5x, and we have the negative 40. And then we see that these two are like terms. So 8x minus 5x is a positive 3x. And then we see that this is exactly the same as that. Number 3, write a plus or a minus sign in each box so that the expressions on each side are equivalent. So remember that we want these two numbers here to multiply to this. Okay, so they need to multiply to the final number, and then they need to add to this middle number, right? So if we look back to this last example, in this box, we had 8 times negative 5, which gave us that negative 40. And we had the negative 5 plus 8, right? So we had this 8 and this minus 5 added together to give us this 3. Where here it was the 8 times the negative 5 to give us that last number. So we want the final term to multiply to the numbers to multiply to the end term, and they need to add to the middle term. So we want 18 plus 3, whatever version we have, to get to 15. So we want it to end out negative. So we're going to want the 18 to be negative and the 3 to be positive, because 18 plus 3 gives us negative 15. And negative 18 times 3 gives us that negative 54. So then in this next one, our final number is positive 54, which means these either both have to be positive or they both have to be negative. So in order to get a positive 21 in the middle, when we add the numbers together, they both must be positive, because 18 plus 3 equals 21, and positive 18 times 3 equals that positive 54 at the end. In part C, we want them to multiply to negative 54. So this means that we need one positive and one negative. And then we want the middle number to be positive. So we're going to want our bigger number to be positive and our smaller number to be negative, because then 18 plus negative 3 will stay positive 15. And then, of course, 18 times negative 3 gives us that negative 54. And then in this final one, we have a positive 54 at the end. So it's got to multiply to a positive, which means they either both need to be positive or they both need to be negative. And we want the middle term to be negative 21, which means we're going to need two negatives, because then we'll have negative 18 and negative 3 when we add those. And negative 18 and negative 3 is negative 21. And negative 18 times negative 3 gives us that positive 54 at the end. Number 4, match each quadratic expression in standard form with its equivalent expression in factored form. So we're going to use the idea that we just did on the last screen to kind of help us. Now you could obviously write these out in the area model and do them. But one thing you can also do is start using your pattern of 5 times 7 will be our last number of 35, and then add them to get your middle number. Okay, so 5 plus 7 gives us 12 for the middle, 35 for the end, and then you'll see that that happens in B. And I guess they want us to match them, right? So then this is going to this one. So B is number 1. Then number 2 has -5 times -7, which again is positive 35 when you multiply. That's going to give us our end term, which now we already know it's got to be D because these A and C have negatives. So then this one is going with number 2 already. And you can check it when you do the -5 plus -7 for the middle term gives you -12, and that matches as well. The third one, when we multiply these numbers together, so 5 times -7 for our end term is -35, which is good because both of these have -35 left. And then when we do +5 plus -7, we get -2 for a middle term. So -2 goes with A. So A is number 3. And then that leaves C to go with number 4. So you can just fill that in if you want to. You can also check it. So -5 and -7, or sorry, -5 and +7 gives us -35. And then -5 plus 7 gives us +2 for that middle term, which does match. Number 5, rewrite each expression in factored form. If you get stuck, try drawing a diagram. So for each of these, they're going to factor into binomials. So I'm just going to kind of get this set up here for each one. So we know it's going to be x plus or minus something times x plus or minus something like we've been seeing in the last couple problems. So let me just get that set up. So then what we want to figure out is what numbers multiply. So these last numbers should multiply to -28 and add to -3. So they need to multiply to -28 and they need to add to -3. So we've got 3 problems with -28. So I think I'm just going to write out the factors of -28 off to the side here so we can look at them. So we've got 1 and 28. 28 divided by 2 is 14. 28 does not divide by 3. 28 divided by 4 is 7. And then 28 does not divide by 5 or 6. So we're done here. And then we know one of these has to be a negative in order for it to multiply to a negative. So I'll just get those written here. And then we want to find in part A the ones that multiply to -28 and add to -3. So this top one adds to 27 or -27. This second one adds to 12 or -12. And then this bottom one adds to 3 or -3. So we like it like this for this top one. This multiplies to -28 and adds to -3. So we want these numbers in here to be a +4 and a -7. That'll get us the -28 and the -3. So then for this next one, I want it to be +3. So if I move the negative back out with the -4, let me get rid of this plus sign in here. So if I move this back out with the -4, then that adds to +3. So then we could do x minus 4, x plus 7. Still gives us -28, but now we have -4x and 7x, which gives us a +3. Then we need 12x in the middle. So now if we go back up to this one, if you remember, this gave us -12. This gave us +12. So if the 2 is negative and the 14 is positive, that will give us a +12 for our middle term while also multiplying to -28 for the end term. And then we need to figure out for negative 60. So again, it's going to be one positive, one negative that add to 28. So if I look at 1 and 60, that's going to be 59 if one of those is negative. 2 times 30 gives us 60. And if one of these is negative, that will give us 28. But I want the negative to be with the 30 so that I get negative 28. So 2 plus negative 30 gives us negative 28. So then we want x plus 2 times x minus 30. Number 6, which expression has exactly one solution? So this one has none because you can't square a number and get a negative, because squaring a number means multiplying it by itself. So that means you're either going to have a positive number times itself, which is positive, or you're going to have a negative number times itself, which is a negative. So there's no solution to that first one. This second one, zero product property, would tell us that x equals negative 5 is the only solution here. So B only has one solution. And if you think about graphing this, it's going to look something like this. It's just going to come down and hit right at that negative 5. Zero product property would have two solutions here, right? Negative 5 and positive 5. So that's more than one. And then D is not having it equal to 0. So this one's going to have, you could graph it like this, similar to that first one where it's going to cross at negative 5, but then the solutions are going to be where it crosses the 36 line, the y equals 36 line. And then you'll see that there's going to be two solutions to that. So B is your answer. Number 7, the graph represents the height of a passenger car on a Ferris wheel in feet as a function of time, seconds. Use the graph to help you find h of 0. So h of 0, remember, is going to be right here at 0. And what's the graph on that 0 line? And that is here. And we've got 1, 2, 3, 4 dashes splitting up 20. So 20 divided by 4 is 5 for each of these. So that first dash is at 5. Does h of t equals 0 have a solution? Okay, so does the function equal 0 have a solution? And the function equaling 0 is here. So remember, that's talking about the height of the function. Does the height of the function ever equal 0? And that's no. We never see it cross there. No, the graph never touches the y equals 0 line, which is the x-axis. And that would also make sense because the height of a car on a Ferris wheel shouldn't hit the ground, right? You don't want to be going up and then smacking the ground every time you go around. So you could also write something like that it makes sense because you wouldn't want your Ferris wheel car to hit the ground. Then it says, describe the domain of this function. So remember that the domain is your x values, okay? So your domain are all of these time values represented, and it appears that it's just going to go, twice around, okay? It's going to go up to its max, back down, and then go around again. And so the domain here is numbers from all real numbers 0 to 60. Now, if this kept going, if we just kept doing this indefinitely, then it would just be all real numbers above 0, 0 and above. But it looks like they're saying it stops after 60 seconds, like you just go around the Ferris wheel twice. And then describe the range. So the range is the output values, okay, or these y values. So you look at the top of the graph, how high does that go? And what's the very bottom of the graph? So this is from 5 to 55. So all real numbers, 5 to 55, which means that you get in your cart on your Ferris wheel, get in your chair at 5 feet above the 0, And the highest height that you get to is 55 feet above the ground. Number 8, Elena solves the equation x squared equals 7x by dividing both sides by x to get x equals 7. She says the solution is 7. Lynn solves the equation x squared equals 7x by rewriting the equation to get x squared minus 7x equals 0. When she graphs the equation, the x-intercepts are 0, 0, and 7, 0. So she says the solutions are 0 and 7. Do you agree with either of them? And explain or show how you know. So you can plug these in, right? So you can take these two solutions and plug them into here. So we could do 0 squared. Does that equal 7 times 0? And you get 0 equals 0. So this is a solution. And then you could plug in 7. So 7 squared, does that equal 7 times 7? And you get 49 equals 49. So that is a solution. So we know that Elena is wrong because she's missing a solution. Okay. And anytime you divide by a variable, okay, so you can divide both functions by numbers, but when you divide by a variable, you lose a solution. You lose when this solution equals 0 because we can't have division by 0. And so you end up losing a solution. So Elena lost a solution by dividing by x. So I agree with Lynn. You can kind of prove it a couple of different ways that you know that both of her solutions work, right? So 0 plugs in and gives you a true statement. 7 plugs in and shows you that it's a solution. So obviously Elena is missing a solution there. Number 9, a bacteria population P can be represented by the equation P equals 100,000 times 1/4 to the D power, where D is the number of days since it was measured. What was the population 3 days before it was measured? So remember, when we're talking exponents and we're talking before, that means that we need to plug in a negative exponent. So we have 100,000 times 1/4 to the negative 3 power. You could also think of doing a 1/4 factor backwards. So taking the initial population and multiplying by 4 instead of doing 1/4 of it, and then do that 3 times. Or you can plug it into your calculator and you would get 6,400,000 for 3 days before this was measured. And then what was the last day when the population was more than 1 million? So on this one, I am going to just do kind of the backwards version, or the undoing of 1/4. So the opposite kind of 1/4 is multiplying by 4. So to go backwards, that's multiplying by 4. So if I multiply this by 4, that gives me 400,000. This was 1 day before. And then if I take that 400,000 and I multiply by 4 again, so then this gives me 1,600,000. And this is 2 days before. So that would be when it was over 1 million, right? 2 days before. So it was the time that they started was 100,000. 1 day before was 400,000. And then 2 days before was 1.6 million. So 2 days before was the last time it was over 1 million.